I guess welcome to Michigan for the people that haven't been here before. I am up in the northern part of Michigan. If we can, yeah, I guess we can see that. This kind of small print down here, but that's Detroit down here. I live up in the northern part of Michigan. It's a resort area where everybody comes to play, and I get to live here, and great place to live, and we love it here. I'll chop this little, this might fit in between the hole of the faceplate, but I don't want to make sure that it doesn't hit shoulder on the spindle. It doesn't have to be pretty, it just has to be pretty much gone. Alright, so let's put a faceplate on here. Now this is roughed out at this stage, so I'm not worried about it being perfectly centered. It's just come close. And I'm going to use now number 12 pan head sheet metal screws. Number 12 is important because that changes the Phillips drive to a 3 Phillips, and the bigger 3 Phillips last a long time. I bought a box of 100 of these probably 30, 40 years ago, and I still got 50 or 60 of them left. And the sheet metal screws have a sharper thread and a better thread than wood screws do. So we're going to use these. And now I'm going into end grain, and this is easily stripped. So I have lots of holes in my faceplate because I may strip 1 or 2 of these. And so I've got 8 holes, 8, 10, 12 holes in a faceplate. You got a faceplate and you decide, oh, Lyle's got a good idea. I think I'll dust off an old faceplate, and you see it's only got 3 or 4 holes in it. You got to drill more holes in it. It doesn't have to be done by a machinist. You can just take it over to even a hand drill and drill more holes in it. Okay, I'll use an impact driver here and seat these. Oop, I think I stripped that one. Went a couple turns too far. Let me take a quick look. Looking all good. All right.
Lyle, I have a question, if I could.
Please, yes.
I own several faceplates that actually came with countersunk holes. So is there a reason I would not want to use a countersunk head screw?
Yes. How can I explain this? There's tolerances in the hole versus the size of the screw, right? And if you're using a counterset screw with a tapered screw and a counterset hole, when you first start that drill, it's not in the center of the hole. And now all of a sudden you hit that shoulder, and that shoulder is going to want to kick the faceplate sideways, or move it around the circle, whatever. And if you do that with 3 or 4 of them, the screws are starting to arm wrestle themselves. They're fighting in different directions. They're all going in different directions because of the tolerances in between the hole and the screw. So it'll work okay probably, but I prefer to have the pan head so it sits on top of the faceplate, not in the recess. Okay, great question. Nobody's asked me that in a long time. That's a good question.
Thank you, that makes sense.
Okay, it'll work probably, but there's a minor problem there that's probably not worth too much effort, but that's why I use the flat. And I guess because I am traveling all over and using different faceplates and different lathes all over the country, I really needed the flat because all the faceplates were all different from different manufacturers. So okay, good question. Thank you.
How long were the screws?
Oh, sorry I didn't mention that. 1.25 inches is all we need. Don't need them any longer. We just need a lot of them. Okay. All right. So let's go back to here. And we're going to get rid of the tailstock. We don't need it anymore. Don't want it anymore. It's just in the way. Love my robust with my tilt-away. All right. So now we've got a good secure grip of this. Nothing bad can happen again. Safety issue. Let me move this camera over a little bit. Sorry it's on, but we're going to move it anyway. There we go, so you can see the profile of what's going on. Now, technically I should turn the speed down. I guess I will, just in case this is wobbling a bit. And chances are it's going to wobble a little bit because I wasn't really perfectly true. See, it's wobbling a little bit, but not enough to cause any problem. I'm going to get the speed back up again. Okay, and now that it's round and all those corners are gone, I'm all the way up to maybe 1700 RPM. Okay, so now let's get rid of some. This might make some of you a little bit uncomfortable here, but I'm going to waste some wood away. I've got the size of this block on purpose bigger than what I need it to be because I don't want to have vibration issues of the wood flexing. So now let's get rid of some of this wood and take it down to my ball size of my. Let me see what we got here. That's about 3 inches. That's good. Let's do 3 inches for the ball. All right, so my ball is going to be up here, and I'm going to keep all of this waste wood now in here just to support it and give me a base that is going to stay there for pretty much the duration. A good example of a vibration issue would be when we do a goblet. Okay, what happens when we do a goblet? We have to keep a whole bunch of wood here to support the goblet. When we make our goblet and we hollow it out, we can't make the stem first and then go hollow out the goblet. It would flex and vibrate. All right, so the same thing can happen with a piece of wood. When we take a hollow form down to a small foot and go out and hollow it, it's going to flex and vibrate. Okay, well, how do we fix that vibration issue? We could put a steady rest on it. God forbid I don't use steady rests either because I don't want to have the limits of the fix. The Band-Aid has unintended consequences. And so I would rather prevent the problem rather than put a fix on it later. So if I'm using a steady rest, I can't do pieces with voids in it, and I have to make a race for it. It starts to influence my design decisions. Lots of bad things happen with a steady rest. So I can keep that wood behind larger than what I need it. This stuff grows on trees. We can waste a little bit of it. So I'm going to make a waste wood area here that's going to hold this up so that the wood can't flex. But one of the 3 vibration issues is the wood that itself can flex. So I want to prevent that, and that's why I make this this waste wood so big. The other issue we skirted on there is the chucking method. You don't want the chucking method or your lathe spindle size or the chucking method to fail the holding power. And so we need to make sure that we're using good techniques for how we're going to hang on to this wood. The third vibration issue is we can exceed the limits of our tools. If we're using a boring bar, we dangle off the tool rest so far and the bar just starts to flex and vibrate. We can't exceed the limits of our tools. We just need to use a bigger boring bar if we want to go deeper, or we can even exceed our limits in the bowl gouge or spindle gouge that we're using. I choose to use a big, this is our spindle gouge here. I choose to use the big 5/8 inch spindle gouge. We get our access to fine detail by the steepness of this grind, not the size of the tool. I can do little things with a big tool, but I can't do big things with a little tool. The little tool dangles off the tool rest. It starts to vibrate. You ever get that little whining, that little sound? Not good. We don't want to go there. Leaves a washboard effect and can make some bad things happen. So we want to stay away from vibration. Vibration is the enemy, and so that's why I've left this waste wood on here the way that I did. All right, let's go back to the Christmas ornament again. So I want to do something about, let me clean up this end. I've got the drive teeth in here that need to go away and clean up this end a bit. Got my tools a little bit too, oh, there we go. Again, last chance here, but I want to make sure, take a good close look at this. Ooh, there's some more woodpecker damage. Loving it. That's going to be right on the top of my Christmas ornament. Okay, everything's good. No cracks, no ring shakes, nothing going on that I'm worried about here. Okay. So, let's make a little bit of a cylinder shape first. I guess you don't need to, but just so visually so you can see what's happening. Let's make a little bit of a cylinder. So I'm going to lower my handle and do a pull cut here and just clean this off. And now that's about 3 inches in diameter. Let me go a little bit more. All right, so now let's talk about some design decisions. I guess let's leave that camera there. Let's use that one. I've got 3 scrap pieces that I used, that I did. One of these, I don't remember which one I did at the vendor showcase event, but this one here is a little bit smaller height than it is diameter, right? This one's closer to a globe or a sphere shape, but it's still smaller diameter or smaller height than it is diameter. And then here's one that's quite a bit smaller height than it is diameter. All right, so this scale here is important to what that Christmas ornament is going to look like. If you want to do a perfect sphere here, like you would see in a Christmas tree purchased glass ornament, that's very difficult. If you're using a sphere jig or something and can do that, that's fine. But to do it by hand is very difficult. It takes a lot of practice, and you can do it. It's achievable. But what if you miss it just a little tiny bit? It really doesn't look good. It looks like you missed it. So I don't want to miss it. I want to do it on purpose and make it look like it's not a sphere on purpose. If you come close to a sphere, it looks like a mistake. So you either do a perfect sphere or less than a sphere completely, and just make it the proportions so that it doesn't even come close to a sphere. Okay. I want to show you here some other things. Let's go back to this camera again. All right. I don't know. I think we can zoom in a little bit in here. There we go. All right. So now this orientation, end grain orientation, is the same as this one was. This is the fruitwood heartwood contrast of a piece of cherry, and the grain orientation is going up and down north-south, right? And that looks very nice. It's very pleasing. This has got a bit of a ring shake here that was in that piece of cherry that I captured. It was still safe enough to turn, but allowed it to stay in there. So it has lots of character in it. And but the grain orientation is north-south, all right? Let's look at this one, all right? Now, the surface is never sanded. This is just off the tool, so it's not a very good, hopefully you can see that. The grain orientation is running across it. It's wavy across it, but this grain is running east-west, all right? Is one better than the others? They're different. See now the fruitwood heartwood contrast is on the either the top or the bottom. I would think the top might be like snow on here, but you see the annual rings are in layers now going across, so much different in its look just because we changed the axis. Okay, so which do you like better? Which you want to do? Who's in control? This is one that's a cherry burl piece here. And so it's got lots of different character in it, but has still a little bit of straight grain wood here. And so I imagine that most of you, if you've done any woodworking for any length of time, you've got all kinds of little scrap pieces of cherry burl or bird's eye or whatever it is that you have cherished and found to do something out of in the past, and you've got these little cutoffs laying around that are ready to do Christmas ornaments in. So take the orientation that you want, pick something special that you're going to get from a burl or the character of the wood, and make some Christmas ornaments that are really kick it up a notch. Okay? All right. So in this case, we've got the grain orientation running parallel to the bed. And it's just because I like it that way, and that's I want that grain to be the strong grain of the elm to be a strong character in the Christmas ornament. All right, so now I've got just 3 inches, and I'm going to make this, well, let me make it maybe about 2 1/4. I'm going to make it a little bit bigger. I come down here. I can taper some of this wood. I still need this wood here for support. I'm going to leave it there for as long as I can. But I'm going to say maybe my bottom is somewhere about here. Okay? About 2 1/4 by 3. That's going to give me a bulgy shape, not a sphere shape.